Okay, good morning class, right? Okay, so today we continue to discuss, from our previous, lesson. Okay, so now, okay, before we answer the next question, okay, so I will explain a little about stoma, okay. So stoma is actually the opening, right? The opening, okay, of the leaf here, right? So this is the opening. So this is called as a stoma. Okay, so the one that control the opening of the stoma is actually we call it as a gut cell. Okay, so the gut cell control the opening and closing of stoma. Okay, so during the day, stoma open to enable exchange of gas. Okay, at the same time, water vapor will be lost from the leaf and this will increase the rate of water intake by the root. Okay, so during the day, the stoma will open. Okay, so the gut cell will open the stoma here. Okay, for the gas exchange. Okay, so during the daytime. Okay, so the plants do the process of photosynthesis. Okay, so there is need of exchange of gas. Okay, so the carbon dioxide, will be absorbed. Okay, and then the oxygen will be released. Right. So that's why the stoma need to be open during the daytime. Okay. But let's say the temperature is too high, right? So if the temperature is too high, okay, the stoma will close, right? So the gut cell will close the stoma. Okay. So this one is to avoid, okay, that too much of water loose, okay, during the hot day, right? So this is the stoma. Okay, so how does the how does the gut cell control the stoma? Okay, according to the temperature, okay, of the surrounding, right? Right, so the next one, okay, the next question. So every weekend, okay, Sukri spends his evening by doing recreational activities, okay. So diagram 5.1 shows the condition of Sukri after exercising, okay. So first question, explain the effect of the activity carried by Sukri, okay, on the rate of respiration. Okay, so of course, if you are after you doing exercise, okay, so the rate of respiration will increase. Okay, so why is it increase? Because to increase the oxygen supply. Okay, so increase the rate of respiration to increase oxygen supply. Right? Okay, for B, during respiration, oxygen will combine with hemoglobin to form a new substance. Okay, so write down the word equation for this reaction in the space below. Okay, so this one, the oxygen will combine with hemoglobin. Okay, so when oxygen combine with hemoglobin, it will form the oxyhemoglobin. Okay, so the oxyhemoglobin is not stable. Okay, so when it travels to the other part of body that needs the oxygen, okay, the hemoglobin will release the oxygen. Okay, the oxyhemoglobin, it will release the oxygen and now it only become hemoglobin. Okay, so this is the equation. Okay, when the oxygen combine with hemoglobin. Alright, the next one. Okay, so carrying out a vigorous activity, okay, causes the body to lose a lot of water through sweating as shown in diagram 4.1. Okay, so the kidney function in regulating the water content in the body. So explain this process. Okay, so the kidney is actually in the endocrine, no, not endocrine, it's actually for excretory system, right, in for our body, right? So the kidney will decrease the production of urine. Okay, since we lost a lot of water through sweat. Okay, so the kidney will decrease, right, the amount of urine. Okay, so therefore the water content, okay, in the body will increase. Okay, so the kidney will decrease the production of urine. So therefore the water content in the body will increase. So how does the kidney know that it needs to decrease the production of urine? So the hormone, okay, so the hormone, okay, will be released, okay, to give a signal for the kidney, okay, to decrease the production of urine. Okay, this one is called as a hemostasis process, right? Okay, all right. The next one, okay, explain how sweating can cool down the body. Okay, so the sweat gland, okay, the sweat gland will produce a lot of sweat. Okay, so the sweat produced will be evaporate from skin to cool down the body. Actually, the sweat they contain the heat, okay, inside of it. Okay, so when they absorb, so they will absorb the heat too. Okay, so after they evaporate from skin, okay, from liquid to the water vapor, okay, so means inside the sweat there's also uh contain heat inside of it. Okay, so there will be absorbed. Okay, the heat also will be absorbed from the body through the evaporation process. Okay, all right. For D, diagram 4.2 shows the situation in a restaurant. Okay, so explain, okay, the negative effect to the respiratory system caused by the action shown in the diagram 4.2. Okay, so this one is actually people smoking in the restaurant. Okay, so so you know the side effect. Okay, uh the side effect of the smoking. Okay, they can cause a lung cancer, okay, bronchitis, and also emphysema. Okay, and it's because the cigarettes smoke contain tar and also carbon monoxide. Okay, so this is the answer for question D. Okay. Alright, next one. Okay, so we do the revision about sound wave. Okay, so because after this, okay, the question will be involved about sound wave. Okay, so we do a little revision of the sound wave. Okay, so our surrounding are filled with a variety of sound. Okay, sound is actually a form of energy caused by vibration. Okay, so the air molecule will be vibrate. Okay, and it will vibrate, then it transfer, right, the sound energy. Okay, from one place to another place. Okay, so like this, right? If I draw, okay. Okay, so let's say this is a air molecule. Okay, so the air molecule will be vibrate. Okay, so it will vibrate. Then when it vibrate, it will collide with another air molecule. Okay, so when it collide with another air molecule, it will transfer the sound energy, okay, to this molecule. Okay, when it vibrate, then when it collide, so when it collide, it transfer the sound energy to another molecule. Then this one also will be vibrate. Then after it collide with another molecule. So that one after it collide, when it collides, it transfer the sound energy, okay, to the other molecule. So that's how we can hear sound, okay, through the vibration. Okay. Okay, before that, can I ask someone from 3K? Wait, I see who. Can using from 3K, can you take the attendance from for 3K? Yeah, and for 3G, Daisy is here, right? Okay, so Daisy, can you take attendance for uh 3G? Okay, because you already know, right, your attendance for online class will be taken, right, as your how you want where which class you want to enter, so that the attendance for this one, the online class, will be count. Okay, if you want to go to a science class or what class for the next year. Okay, so I want attendance. Okay, Daisy, please take for 3G. Okay, so this is the characteristic of sound. Okay, right. So you know that it transfer to the vibration. Okay, all right. So next one. Okay, so transfer of sound. So sound requires a medium to propagate. So means it needs a molecule, right? The air molecule to propagate. So because I already explained to you that they need the air molecule to vibrate, then collide with another air molecule, then another air molecule will vibrate. So they need a medium. Okay, so means in vacuum, okay, the sound cannot travel. So let's say if you put a bell, okay, inside a jar, and then inside the jar is a vacuum. Okay, so means there's no air molecule. So if you hear from outside, you cannot hear at all the ring bell. Okay, because there's no air molecule that transfer, okay, the sound energy to the surrounding. Okay, so sound requires a medium to propagate, and sound can propagate through liquid, solid, and gas, right? Because solid, liquid, and gas, they got the air molecule inside of it, right? And then, but not through a vacuum. Okay, so for example, when a bell is round, okay, the metal surface of the bell will vibrate. Okay, and the air molecule near the surface will also vibrate and collide with air molecules nearby. Okay, so this vibration is transferred from one molecule to another molecule beside it in the form of wave. Okay, so in this way, the bell produces sound that can be heard by the ears of the listeners. Okay, so let's say this is a bell. Okay, so between the bell, of course, they got a air molecule, right? So air molecule is here, right? Okay. So when it vibrate, okay, when it vibrate and it collides with another air molecule, okay, so this one will also vibrate. So when it vibrate, when it collides to the another air molecule, it's also transferred, right? The wave energy, the sound energy, okay, to another molecule. So this one they got the sound energy, okay, but the sound energy is actually in the wave form, okay, in the wave form, okay, and then this one it will collide again and it will vibrate again, then collide with another one, and then by the time they collide, they transfer the sound energy, okay, but in the form of wave. Okay, transfer sound energy but in the wave form, right? And then after that it will reach, okay, your ears, and also you know inside your ears they got the eardrum, right? So the eardrum is actually will be vibrate also. Okay, so your eardrum also will be vibrate. So that one they can detect the sound. Okay, so actually it's the vibration. Okay, by using the vibration. Yes. Yeah, okay. All right. Next one. Okay, for those who didn't use the MOEID, right? So I'm afraid that maybe your friend didn't recognize you. Okay, maybe using or Daisy cannot recognize because you use another name. So please tell, okay, who are you? Okay, I prefer you use the ID, MOEID, because in your MOEID, they already got your name. So it's easy for your friends to pick your attendance. Okay, so next time, please use your ID, MOEID. If you cannot use it, maybe you can tell your classroom teacher, okay? You forgot your ID, your password or something. Alright, okay, the next one. Okay, speed transfer in sound, speed of transfer of sound in liquid, or speed of transfer of sound in solid, and speed of transfer of sound in gas. So what's the difference? Okay, right, so I explain to you. Okay, so you know the arrangement of molecule in solid. Okay, so in solid, the arrangement of molecule is close to each other, correct? Like this. Okay, so it's close to each other. Okay, so this one is solid, right? Okay, so you know, okay, so let's say I have a bell here. Okay, so let's say I have a bell here. Okay, so then the bell is round. Okay, so and then what happened? Okay, so this one will vibrate, right? So because it's close to each other, okay, so it will be faster, right? So and then when this vibrate, this one also will be vibrate. This one also will be vibrate. Okay, so mean the speed is very high. Okay, the speed of sound will be very high. Okay, the speed of sound is very high. because they are close to each other. So they don't need much time, okay, from for air molecule to collide with other molecule because they're very close with each other. Okay, how about the liquid? Okay, so the liquid, the distance, they got some distance, right? Okay, and then okay, let's say there's a vibration here. Okay, the sound. Okay, so the sound is vibrate, right? So it will vibrate the air molecule. Okay, but it will take some time, okay, to vibrate with another molecule, okay, to collide with another molecule. Then it will take some time, okay, to collide with another molecule, okay. So means the speed, okay, of sound will be slow. Okay, so speed of sound will be slow. Okay, alright. So this is for liquid. Okay, how about gas? Right, so the gas is actually very far with each other. Okay, the distance is further apart, right? So means this one, let's say the energy, sound energy will be vibrate. So means the air molecule here will be vibrate. So but it will take a longer time, okay, to collide with other molecule, and this molecule will take, okay, a lot of time, okay, to collide with another molecule. Okay, so this one, the speed is very, very slow. Okay, so the speed of sound is very slow. Okay, so if we arrange, okay, the speed of sound, okay, so we start from the lower to the highest one. So the lowest one should be gas. Okay, and then second one is liquid. Okay, and the last one is solid. Okay, so means if we go from left to right, okay, the V is actually speed, okay, the V will increase, okay. So I already explained, so that is why, okay, the speed, the sound will travel faster in solid compared to gas and liquid because the arrangement of the molecule, okay, the arrangement of molecule is much closer, so it will not take much time, okay, for the molecule to collide with another molecule to transfer the heat and to transfer the sound energy in the form of wave. Okay, so this is how we explain why the solid is the sound will travel faster in solid. Okay, so we move on to the next one. Okay, so this is the explanation. Okay, why? Okay, so I already explained for you these three. Okay, the solid, okay, the liquid, and also gas. Okay. Alright, so the next one is the reflection and absorption of sound. Okay, so sound can be reflected, okay, and absorbed when it hit the surface of an object. So these characteristics, okay, are the same as the characteristic of light that you have learned in Form 1. Okay, so the amount of sound reflected and absorbed depend on the surface of the object. Okay, so usually the hard and smooth surface, okay, are good for sound reflector. Okay, must be hard and also smooth. Okay, but for the soft and rough surface are actually good for sound absorber. Okay, so let's say in the hall, okay, in the big hall. Okay, so usually when at the wall there, they will put the soft board there. Okay, okay, I'm not sure whether our hall got the soft board or not. I don't think so. Okay, so let's say if you go for the concert in the hall, okay, in the closed hall, right? So they will put the wall there, the soft board. So why they put the soft board here? So that one is actually to absorb, okay, to absorb the sound, so there will not be reflection. So there will be no echo. Okay, so that's why we use the soft board. Okay, let's say for the big hall, they put the soft board at the wall there. So that one is actually to absorb the sound. So there will be less sound that will be reflect. Okay, so means there will be less echo. Okay, that that we produce. Okay, so if you want this good reflector or good sound reflector, you have to choose the hard and smooth, okay, or soft and rough, okay. Also if you go like they will put the carpet also, okay, in the floor. That one is also the same function, okay, to absorb the sound, okay, so will be less echo that we produce, okay. Alright, so we move on to the next one. Okay, loudness and pitch of sound. Okay, so our ears can differentiate the sound that are heard because sound have different strengths, okay, and pitch. Okay, so the strength or loudness of sound is actually depends on amplitude. So this one is very important. Okay, the strength or loudness of sound, it depends on the amplitude. Okay, and then if for the pitch of sound, okay, it depends on the frequency. So how you want to differentiate, okay, between the loudness, okay, and also uh, the loudness and also the pitch of the sound, okay. Okay, sometimes, okay, when you hear people talk loudly, right? Talk loudly, okay. So that one is actually the amplitude is higher, okay. The amplitude is higher, okay. But okay, if when you hear people talk loudly and it hurts your ears, right? That one is the frequency is high, okay. So means the pitch is high, okay. So let's say in the graph. Okay, I give you example. So let's say in the graph, okay, how you want to differentiate what is amplitude, what is actually frequency, right? Okay, so amplitude is, okay, so amplitude, hmm, oh, wait, I admit someone, okay, okay, so amplitude, okay, so this is the graph, okay, I show you the amplitude first, okay, so this is the amplitude, yeah. Okay, so this one is actually to differentiate the loudness of the sound. Okay, so amplitude is actually this one. This is called as amplitude. So if we compare, okay, so let's say this is A and this is B. Okay, so the amplitude of A is higher, correct? So the amplitude is higher means this one, okay, the A is A is louder than B, okay, because it compare the amplitude. Okay, so this is called the amplitude. Okay, right? So what is mean by frequency? Okay, frequency. Okay, for frequency, okay, it's easy. I divide by two. Okay, I draw first. Okay, and this one. Okay, so you can see here the frequency. Oops, sorry. Okay. In this one. Okay. Okay. No. Okay. For this one, you can see the graph. Okay. Compared to this one is much closer to each other, right? So this one, the frequency is high, right? Because it's much closer to each other. Okay. And you know the frequency is actually the number of complete oscillation, right? Okay, so this one is called as one complete oscillation. Okay, this is the graph. This is a time graph. Time Okay, and this one is called as a displacement. Okay, all right. So let's say I put here 2, 4. Okay, 4. This one is 6. This one is 8. Okay, this one is 10. Okay, for this one is 1, 2 because they are close to each other, right? 3, 4, okay, 5, and 6. Okay, so one complete oscillation is actually this, we count it as this one. This is called as one complete oscillation. Okay, this is called as one complete oscillation. So if you can see here, for one complete oscillation, the time is 4 seconds. Okay, and for this one, for one complete oscillation, okay, they only took 2 seconds. Okay, so means this one the time must is lower, right? So mean this one the frequency is higher. Okay, because you know the formula for frequency is 1 over t. So when the t is lower, the frequency will be higher. Okay, so the frequency is higher. So this one, for this graph, okay, the pitch is higher compared to this one. Okay, so I explain again. Okay, if you are using a graph to compare the frequency, because you know the pitch is actually depend on the frequency. Okay, so you have to take two semicircle here. So these two semicircle we count it as one period. Okay, one period. Okay, for these two semicircle we call this as a period. Okay, period. Okay, and then this one also, the two semicircle here, we call it as a period. Okay. And then for this one, the period is 4 seconds. Okay. So the T is 4 seconds. Okay. And then for this one, the period is 2 seconds. Okay. And then if you want to calculate the frequency, okay, so the formula for frequency is 1 over T. Okay. So you can use your calculator. Okay. If you are not sure. So 1 over 4 here, you got 0.25. Okay. Okay, and then for this one, if you use the F1 over T, so the T here is 2 seconds, right? Because 2 semicircle is actually is 2 seconds here. Okay, so 1 divided by 2. Okay, F is 1 divided by 2. So you got 0.5. Okay, 0.5 hertz. Okay, the frequency is hertz. Okay, so if you compare, right, the frequency, you have to know the higher the pitch means the frequency is higher. Okay, so means for this one, the graph, the blue one is higher frequency means the pitch is higher. Okay, so that's how you want to compare. Okay, which one is have the higher frequency. Okay, so I already show you how, right? Okay, for the loudness, we use the amplitude here. Okay, but for this one, you can see the amplitude is same, right? Means the loudness of the sound is same. Okay, but only the pitch is different because the pitch is depend on the frequency. Okay. Alright, so we'll move on to the next slide. Okay, and the frequency is measured in hertz. So this one also I already tell you. Okay. Okay. So this is the graph, right? So this is the graph. Okay. So the amplitude, so this is the normal one. Okay. So you increase the output by output power. Okay. So the amplitude will increase, right? So you can see this one only one box, but this one two box. So means the amplitude is increased. So when the amplitude is increased, I already told you loudness is actually depend on the amplitude. So here the amplitude increase, so means the louder sound is produced, right? Okay, for this one, you can see the graph is much closer. Okay, see the graph is closer to each other compared to this one. Okay, so mean this one, the frequency is higher. But the amplitude same, right? The amplitude, this one is one box, this one also one box. But only the difference that now the graph is much closer to each other. So when the graph is much closer to each other, mean the frequency is high. So if frequency is high means the pitch also will be higher. Okay, so this is how you differentiate, okay, between loudness and also pitch. Okay, all right, next one. Okay, Doppler effect. Okay, so the Doppler effect is the apparent change in frequency. Okay, uh, caused, okay, by the relative movement of sound source, okay, or the relative movement of the observer, or both. Okay, so figure 10.8 show explain the Doppler effect. Okay, so this one, the frequency of ambulance siren, okay, heard by the observer increase, okay, when the ambulance approaches the stationary observer. Okay, so observer, right? So this one, when the ambulance travels, okay, close to the observer here, okay, you can see the pitch, right? So the pitch is become higher, right? The frequency become higher. Okay, so the frequency become higher. Okay, so Doppler is actually caused by the frequency change. Okay, change in frequency. Okay, change in frequency. So when it travel close to the observer here, so the frequency will become higher. Okay, and then when it travels further from the observer, okay, the frequency will decrease. Okay, so this is called as the apparent change in frequency. Okay, so this is sometime with this one you can hear loudly, and this one there will be the sound will become slower. The sound will become slower. Okay, the next one. Okay, phenomenon of the reflection of sound. Okay, so an echo. Okay, so this one I already explained like in the hall. Okay, so that's why they put the soft board here to reduce the effect of echo. Okay, or sometimes, okay, let's say you go to the mountain, right, and then you shout your name, and then suddenly you can hear you can hear back your name, right? So it will be like repeat. So that one is actually reflection of sound too. Okay, so an echo is produced when sound waves are reflected from hard surface to the listener. Okay, so the reflected echo sound the same as the original sound, so, but it takes some time to reach the listener's ears. Okay, so an echo can be heard in place like a closed hall, empty room, cave, tunnel, or gorges. Okay, so observe figure 10.9 to understand the phenomena of echo. Okay. So let's say this one you shout, okay, and then it will be reflected back, but it will take some time. Okay. So you can see the original. This is the green one is the original wave, and the red one is actually the reflection wave. Okay. So you can see it reflect back. Okay, so actually what is the function, all right, the reflection of sound wave? Okay, so there's many functions. So the first one is actually for back, right? Okay, so ultrasound is a type of sound wave with frequency of more than 20,000 hertz. Okay, so let's say if the question asks you what is the ultrasound. Okay, ultrasound is a type of sound with a frequency of more than 20,000 hertz. Okay. Okay, and ultrasound cannot be heard by human, right? So we cannot hear ultrasound, okay, but only can be heard by animals such as bats because they use it to navigate. Okay, so a sound reflection technology known as sonar is used in the shipping industry to detect underwater objects. So this technology is also used in other sectors such as medical and fisheries. Okay, so scan. So this one, if you want, you can scan it. And I got this one is from the textbook. Okay. Alright, so let's say if I explain a little, okay, how does the ultrasound, okay, be used by the fisheries, right? So let's say we take a fisheries, okay, okay. So let's say this is the sea here, okay, and then this is the fish, okay, a group of fish, right? So many fish, okay. Okay, let's say there is a ship here. Okay, so how does the fishermen, right? They know, okay, where to stop the ship, okay, and then know that okay, this part they got many fish here. Okay, so how does they know? So they use the ultrasound, okay, to detect, right? So actually inside the ship, actually this one is for the big ship. Okay, if the small one, they don't have like this technology. Okay, so they got the wait. Okay, so let's say this one, then we transmit, okay, the ultrasound. Okay, then when it transmit, it will hit the group of fish here. Then what will happen to the sound or the ultrasound? Okay, after it been hit, it will be reflected back to the ship. Okay, so when it reflected back to the ship, okay, and then they will use, okay, then we use that reflection, okay, to detect, okay, what is the depth of the group of fish here by using this formula. Okay, so this one is actually a knowledge. Okay, you will learn this in physics if you take next year. So V is equals to 2S over T. So V actually is the value of the speed of for ultrasound. Okay, that one is actually already been fixed, it's constant. So let's say the velocity is 3000. Okay, this one is actually fixed value. Okay, so let's say the example is 2000. Okay, and then the S is actually the distance. Okay, the distance of the group of fish. And then the time is the time taken, okay, for the ultrasound wave to be reflected back, okay, to the ship. So this one they can count, right? So how what is the time that the reflected wave, okay, travel back to the ship, okay? And then let's say they took like 300 seconds. Okay, and then just use the calculation so they can estimate what is the depth of the group of fish here. Then after that, they will catch the fish, okay, according to the depth. Okay, so this one the technology is being used in the fisheries. Okay, so they know where is the where which place have got many fish there, right? And how depth is the group of fish? Okay, how depth is the fish there? So they use this method to detect. Okay, the ultrasound method. Okay, and also another one for the bat. Okay, you know bat cannot see, right? So they use the ultrasound. Okay, so that's how, okay, they can navigate. Okay, they can navigate, okay, or can detect the prey. Okay, so they use the same method as the fisheries, also same, right? They estimate, okay, let's say they release the ultrasound energy, they release the ultrasound, okay, ultrasound wave, okay, and then the ultrasound wave will hit the prey, okay, and then they will reflect it back to it, to the bat, right? And then they can estimate, okay, what is the distance of the prey, okay, before they attack the prey. Okay, so that's how they use in the for the bat. Okay, same method. Okay, by using the reflection of wave. Okay, all right. So next. Hmm. Okay, limitation of hearing. Okay, so the frequency of sound that can be detected by human is within the range of 20 hertz to 20,000 hertz only. So this is our range of hearing. Okay, 20,000 hertz is actually above, is like ultrasound wave, right? So that's why we cannot hear, because ultrasound wave is 20,000 hertz. Okay, so we cannot hear that one. Okay, so this range become narrower as we age because our ears lose their sensitivity to sound frequency. So when we got older, so we lose our sensitivity, okay, because you know the eardrum there, the eardrum need to vibrate, right? So when we become older, the eardrum will become more stiff. So when it becomes stiff, okay, it will lose the ability to vibrate. Okay, so that's when we come old. So that's why we lose, right? We lose a little we lose our sensitivity to sound frequency. Okay, on the other hand, animals have their own limit of hearing. So bats, dolphins, and dogs are example of animals that have a high range of hearing than humans. Okay, so this is the hearing range here. Okay, alright, and then the limited sense of hearing in humans makes us unable to hear soft sound and sounds from distance. So therefore, we need to use a special devices to overcome this limitation. Okay, so this one we use a stethoscope. So this is for doctor to listen the patient heartbeat. Okay, a megaphones. Okay, so this one is to amplify the voice. Okay, so that they can hear from a distance. And this one, they say if you have let's say someone they lose their ability to hear, right? Okay, so we use the hearing aids. Okay, so this one can amplify sound entering the ear. So this is the devices that we use to overcome these limitations. Okay, all right, we move to the next question. Okay. Alright, so diagram 5.1 shows the method used by the fishing boat to detect the location of the fish in the sea. So this one already explained to you. See the transmit the ultrasound here. So let's say there's a fish here that will be reflected back. Okay, and then there we estimate, right, what is the depth of the group of fish here by using the formula there. So the V is actually they got constant value. It's like the gravity. Gravity is always 10 ms negative 2, right? So let's say same also for the ultrasound wave. Okay, the value is constant. Okay, and the time is actually depend how long does the wave takes time to travel back to the receiver, for the ship here. Then they can count. Okay, what is the depth of the fish here? Okay, name the technique used to detect a fish as shown in diagram 5.1. Explain your answer. So this one use the ultrasonic sound. Okay, and then the sound will be reflected when it reach fishes. Okay, so the distance of the fish can be estimated. Okay, by use the formula V is equals to 2S over T. Okay, but that one you don't it's just a knowledge. Okay, so later if you take physics, okay, Form 4 you will learn that one. Okay. Alright, and then for number 2, name one animal that applies the characteristic of sound waves stated in 5A1. So this one is a bats. Okay, for B, sound is a form of energy. So how is the sound produced? So sound is produced by vibration. Okay, produced by vibration. Okay. Alright, so next one. Okay. Alright, so Amina found out that when she blows at the mouth of the bottle with different volumes of water, different volumes of water, different pitches of sound are produced. Okay, so complete the following table with the word given. Okay, so when the volume of water is 0, okay, means it's empty, so the pitch of sound is high. So the pitch is depend on frequency, means the frequency is high. Okay, if the volume of water is 250, okay, so 250, the pitch of sound will be medium. Okay, but if it's full, okay, so the pitch of sound will become low. Okay, so this is the answer for C. Okay, so doctor commonly use ultrasound to scan devel doctor commonly use ultrasound to scan a developing fetus as shown in diagram 5.2. So explain how the ultrasound wave is used to produce the image of the fetus in the womb. Okay, so the ultrasound wave will be reflected by the babies and produce image at the screen. So this one is the function of the ultrasound wave. Okay, by using the reflection of wave, okay, in the medical field, okay. So this one they use the ultrasound wave, okay, to scan the baby inside the mom, to scan the fetus, alright, inside the mom wombs, okay. So this one is to explain how the ultrasound is, so they use the reflection of wave, okay, by using the ultrasound wave. Okay, so the ultrasound wave will be reflected by the babies and produce image at the screen. So why we use the ultrasound? Why not using the X-ray? Okay, so it's because it's not harm to human. Okay. Okay, for number 3, give one other use of ultrasound wave. So you can say use in fisheries. Okay, so this one is for the medical. Okay, so you can say use in fisheries also can. Okay, this one is for the group of fish there, right? We want to detect, okay, like this, right? Okay, the next one, okay, living things and non-living things are matter. Okay, so what is matter? So matter is the substance that has mass and can occupy space. Okay, such as solid, liquid, okay, and solid, liquid, and gas. Okay, that one we call it as a matter. Okay, so matter. Okay, under matter, okay, there are three parts. Okay, solid, liquid, gas. Okay, so three part of it. Okay, alright, and then next one. Okay, state one example of non-living matter. Okay, so non-living matter is a wood, metal. Okay, okay, non-living matter. Okay, and then state one example of non-matter, light. Okay, because light we cannot hold, right? We cannot hold the light. Okay, because light is the energy, right? We cannot hold, we cannot smell. Okay, so that one is a non-matter, light. Okay, heat. Okay, we cannot hold the heat. Okay, we cannot smell the heat. Okay, so that one is non-matter. Okay, the next one. Okay, Ahmad wants to ride his bicycle. Okay, to the mini market, but he finds the tire flat. Okay, so he pumps air into the tire as shown in diagram 6.1. Okay, but Ahmad does not pump the tire too full, so justify Ahmad action. Okay, so this one to avoid too much pressure inside the tire. Okay, so when you pump the tire, pump the air. Okay, so let's say okay, so let's say this is the tire. Okay, so you pump air inside of it. So what does it mean if you pump air inside of the tire? So means you add more air molecule inside of the tire, right? Okay, you add more air molecule. Okay, so when you add more air molecule, okay, so what will happen inside the tire here? Okay, so they will collide with each other. Okay, and then they will collide with the wall of the tire there. So when they collide with each other, they will produce a pressure. Alright, so if you put too much air, okay, inside the tire here, okay, if you put too much air, so what will happen? The rate of the collision, okay, between the molecule and also the wall tire will be increased. So they will be keep collide with the wall of tire here. And then what will happen? Okay, right? So that is why we want to avoid that, right? So we don't want too much pressure. Okay, because when the collision, the rate of collision of the air molecule is increased, the pressure inside the tire will also be increased. Okay, and your tire will become, I think, hard, right? Okay, so that's why we don't pump the tire too full. Okay. Alright, the next one, the bicycle tire become flat when the weather is cool. So explain. Okay, so when the weather is cold, the temperature is low. Okay, so when the temperature is low, the kinetic energy of the molecule inside the tire will be decreased. Okay, the pressure of air tire inside the tire decrease. Okay, so that's why it become flat. Okay, so inside of it, I already explained there will be a air molecule inside of it. So when it's cool, okay, when it's cool, okay, when the temperature is low, okay, the air molecule will move slowly, okay, because, okay, the kinetic energy will become low. Okay, so it will move slowly. When it moves slowly, so means there will be the rate of the collision, okay, between the air molecule and the tire also will be decreased. So means that inside this one, the pressure also will be decreased. So that's why the tire become flat. Okay, so you have to remember, okay, when you apply the heat to the air molecule, the air molecule will move faster. Yeah, I think you already know that. Okay, so okay, I give you an example. Let's say I have a beaker here, okay, and I close it, okay, and there is a air molecule inside of it. Okay, and then I heat the beaker here. So what will happen to the beaker? Okay, so here the molecule will move faster. Okay, move faster because you heat the air molecule, right? It will move faster. So when you move faster, the kinetic energy also will be increased. Okay, and then the rate of heat, the rate of collision between air molecule and the wall of the beaker also will be increased. And remember, I told you the pressure is caused by the collision of the air molecule to the wall of beaker here. So if them heat more, the wall beaker means the pressure will be high. Okay. And then after some time, okay, if the temperature is too high, the molecule move faster. What will happen? The beaker will break. Okay. So that's how happen here also. Let's say if I put in the fridge, okay. So if I put in the fridge, what will happen to the air molecule here? Okay, so the air molecule will move slower. Okay, it will move slower. So when it moves slower, the rate of the collision between the air molecule and the beaker also will become lower, right? And then the pressure also will become lower. Okay, so it's same like the tire here also. Okay, if you put in the cool weather, okay, the temperature is low, okay, and then the air molecule inside the air tire here will move slowly, okay, and then the kinetic energy also decrease, okay, and then you already know, okay, if they move slower means the heat, the collision between the air molecule and the tire also will be decreased, okay, and then the pressure also will be decreased. Because pressure, it depends on the collision of the air molecule to the wall of the container. Okay, so this one is actually wall of the tire. Okay, so I hope you understand. Okay, and the last one. Okay, you are given a bottle of soft drink and balloon. Okay, so explain how to carry out an experiment to show the property of matter. So state the property of matter that you study in the experiment. Okay, so this is the how you do the experiment. So this is the result. Okay, you put the balloon, okay, at the mouth or at the opening of the bottle here. Okay, and then you shake it. Okay, and then there will be release of carbon dioxide, right? The gas will be released and it will occupy the balloons. So this one is actually the experiment is to, okay, to investigate, right, whether the air can occupy the space. Okay, the air can occupy the space. Okay, right. So this is how you explain how to carry out the experiment. Okay, so open the soda bottle, immediately stretch the balloon's opening over the neck of the balloon. Sorry, of the bottle. Okay, and then the carbon dioxide gas will be released out. Okay, and then the balloon will become bigger. Okay, so this is actually to investigate that the air can occupy the space. Okay, so this is the answer. So I think we finished already for the first set, I think. Okay, and then next week, no, on Friday, right? We have one another class. So we continue to the next set. Okay, this one already give you in the group, right? So you can print out or you just can see through your phone, okay, and try to answer it first, okay, and then after that we will discuss, okay. So using later, you give me the attendance through WhatsApp, okay, WhatsApp, okay. I want the attendance, okay. All right, thank you, class. Okay, see you next week.